Hello, this is Mr. Huber. In this lesson, we're going to look at parabolas and some of their more detailed features. We've seen basic equations of parabolas and y equals x squared, and maybe we'll look at how do I find the axis of symmetry in a vertex. And now we want to see when those graphs are shifted a little bit, and even when they're flipped, and we might see a parabola that opens left or right, how those things look. So you can see from what we have down here, okay, the vertex is going to be h comma k. So when we see in these equations h's and k's, those are the x and y values of the vertex, right? Let's talk about a vertical parabola. Those are ones opening up or opening down, okay? They're going to have a y equals, and then the x is going to be what's squared. Okay, y equals, and then the x is what's being squared. That's a vertical parabola opening up or down. If this number in front here is a positive, it opens up. If it's negative, it opens down. And we're familiar with that. The focus and directrix are two kind of new things here. Okay, the focus is a point that's inside of the parabola, and the directrix is a line that is the same distance from the vertex as the focus, but it's outside of the parabola. So we're going to see some examples of what those look like, but be aware the focus is a point inside the parabola, and the directrix is a line, right? You can see focus is a point, right, an x and y coordinate, and the directrix is a line. Okay, that's in this case going to be horizontal. When we see down here, x equals, that's a vertical line. So horizontal parabolas are going to have equations that have this general form. This is the x equals, and the y is being squared. So again, vertical parabola, y equals, horizontal parabola, x equals. Here, when this in front is a positive, it opens up. Here, when it's a positive, it opens to the right. If it's a negative on this horizontal parabola, it's going to open to the left. And so we can see the h and the k from our vertex, right? Those are key parts of the equation. H and k, key parts to our equation, the x value of the vertex, the y value of the vertex. And the thing that's looking a little different is the p. And we see p in here. There's an equation. It's in here, k plus p. What is that? This p is the distance from the vertex to the focus. It's also the distance from the vertex to the directrix. The vertex is in the middle of the focus and directrix. Okay, they're going to both be the same distance away from the vertex on opposite sides of it. So that p-value is the distance. That's why the focus here is h. So it's our x value is not changing from the vertex. But the y value is going to be k plus p, right? It's going to go up from the vertex, or if p is negative, down from the vertex. Okay, so we can see where the p-value will come in, and we're going to see how we can use that in writing equations and drawing graphs. Okay, so focus and directrix. Key thing here is that those are the same distance away from the vertex. Okay? Focus is a point inside of the parabola. Directrix is a line. Okay, that's the same distance from the vertex as the focus is. All right, so let's see what a couple of those graphs look like. Okay, so here's a couple of examples of graphs of vertical and horizontal parabolas. Vertical parabola, again, opening up, or it could open down. Okay, we have an example one opening up here. In this case, the vertex right here is at 0, 0. The focus would be 0, whatever p is. Okay, so if p is 3, this would be 0, 3. And the directrix would be the line y equals negative p. Okay, right? So we see down here, the directrix is this line that's the same distance away from the vertex as the focus. If this is a distance of 3 here, then this is a distance of 3 right here. Okay? And if you're wondering what the directrix is useful for, it's a line where if you take a point anywhere on the parabola, okay, the distance from that point to the directrix is the same as the distance from that point to the focus. So the directrix is always the same distance from any point on the parabola as that point to the focus. And again, you can see the focus is this point inside the parabola, and the directrix is a line that's not going to intersect the parabola anywhere. That's the same distance away from the vertex as the focus is. Here we open to the side. Okay, so our vertex here is at h, k, whatever those values might be. All right. If the distance to the focus here is 8, then the distance from here back to the directrix is 8. Okay? This value is going to be h minus p. Whatever this h value is, if this is 2, and we go 8 this way, 2 minus 8, this would be at negative 6, right? This directrix is always going to be h minus p, and we can see that up here. We talk about how do we find the focus and directrix for vertical and horizontal parabolas, right? Do we want to be aware? The distance from the vertex to focus is the same as vertex to directrix. Right, this would open right, meaning this would have been a positive here in front of the y squared. Right? So you see a couple of general examples here. Now we're going to see what they look like in some actual problems. But the key here is to know those equations and know how to find a focus and a directrix. All right, those are going to be our key parts to this. So let's write an equation. We have a parabola with a vertex at 1, 3 and a focus at 2, 3. I'm going to draw a quick sketch. Okay, we don't necessarily have to graph this, but I want to show when we see what this is going to look like, how that might be able to help. So the vertex is at 1, 1, 2, 3. That's the vertex right there. The focus is at 2, 3. So if you recall, the focus is always going to be inside the vertex. That means, or inside the parabola, excuse me, we're going to expect a parabola that goes like this. It's opening to the right. So we would know now that it's going to be in the form y equals, or excuse me, x equals with a y squared, because it's horizontal. Got to catch myself there. So it's a horizontal opening parabola, so it's going to be an x equals with a y squared. All right? So we're going to use the general form, x equals 1 over 4p. How do I know what that p value is? Okay, that's the distance between the vertex and the focus. That's a distance of 1. So we can put in here for p 1. Right? That's because this distance right here is 1. Then we're going to have y minus k. So it's y minus the k value, which is the y value of the vertex. So y minus 3 plus the x value of the vertex, 1. So this is our k, and this is our h. Y minus k plus h. So now, I just need to multiply the 4 times 1 if I haven't done that already, see if there's anything I'm simplifying. So I'm going to have x equals 1/4 y minus 3 squared plus 1. Because we forgot the squared there. Don't forget that squared on the right side of the equation there. That's our equation. Okay. So we use the vertex as our h, k. And the focus, the 2 and the 3 for the focus were important in terms of knowing which way the graph was going to open. So we knew which type of graph and equation we should be writing. So let's see another example here. Now we're going to write the equation of a parabola with a vertex at the origin and a directrix of y equals 4. So again, let's just draw a quick little sketch of what that might look like. So vertex at the origin, okay? That's 0, 0 for our h and our k. So 0, 0 is our vertex. Directrix at y equals 4, that's a line like this. That's the directrix, y equals 4. So the focus would then be the same distance on the other side of the vertex. There's our focus. This is the vertex, this is the focus. So we know our graph's going to do this and open down. So it's opening down, that's going to be a y equals with the x on the side that's being squared. So we're going to have y equals 1 over 4 times p. Again, what's p? Well, that's our distance between the vertex and the focus. That's a distance of 4. So we'll put a 4 in for p. Then we're going to have x minus 0. Change that back so we don't get confused. This is not coming from the p value. Okay, that's the 4 only. So now I'm going to have x minus 0 squared plus 0. Right? This is my h and my k. H goes with the x. Up here, k goes with the y. H comma k, think of it. H, that's your x value. K, that's your y value. Okay. So now I can do some simplifying, especially with those zeros there. I'm going to have y equals 1 over 16 x squared. X minus 0 is just x. You don't have to write the plus 0 either. That would be our equation for that parabola. Again, the focus and directrix are important for helping you know what the p-value is in terms of writing the equation. All right, before we look at a couple drawing our own graphs, the puck stops here. The video doesn't stop here. We got two more examples. But the puck stops here. How did the standard ice hockey pucks we know today come into use? Okay, when ice hockey was first started, legend has it they actually used frozen cow manure. Not sure if that's accurate. I wouldn't be able to verify it, but that's what they claim. Okay, you see that different places, and I've heard that before. So they used frozen cow manure. Luckily, they evolved a little past that. And actually, balls were used before pucks were used until the late 19th century. In the 1870s, they started using wood and rubber to make pucks. So they actually started using wooden pucks as well. Part of the reason for that was the wood would stay in play. It wouldn't bounce around as much. Rubber bounced around a lot. Now they freeze pucks to keep them from bouncing around as much. But before they figured out, wood pucks actually used a little better, and they were actually wood balls first. Okay, and then square pucks were used. So you see in the middle there a picture of an old-time puck that was actually more of a square. And some of the first rounded pucks came from taking the balls that were used and slicing them in thirds, getting rid of kind of the top and bottom, and then what you had left over, that disc in the middle, they kind of rounded those out, and they used those as the first pucks. So that was around the 1880s. Okay, they were square for a little while, and then from the 1880s and on, it became more standard to use discs and pucks, and then getting away to the more traditional rubber pucks we know today. All right. Let's look at graphing some parabolas, okay? So the directions say to identify the vertex, focus, and directrix. Those are going to be important for drawing the graph. We need to know where the vertex is to even draw the graph, okay? The focus and directrix, we need to know where those are so we can place them on the graph, okay? And then knowing whether it opens up or down will help with where the focus and directrix are, and also this value in front of, right, the y squared. That tells us already we have an x equals. So x equals means this is going to be a horizontal graph. It's either going to open left or it's going to open right. The negative in front of here tells us it's going to be a graph that opens to the left. Okay. So let's first identify the vertex. Okay. The vertex would be the h and k values, which in this equation, there are no h and k values. Doesn't mean it doesn't have a vertex. It means the vertex, okay, is at 0, 0. So we have a vertex right there, 0, 0. Now we want to talk about where the focus and directrix are. This is where we're going to use the 1 over 4p, okay? So 1 over 4p, okay, equals negative 1/2. Remember in our equation, this here is 1 over 4p. So we can write that equal to 1 over 4p, and we'll be able to solve this now for the letter p and find out what that value is, which will help us determine where the directrix and focus are. So in this equation here, right, we're going to have negative 2 equals 4p. If you're wondering how I got that, I can cross multiply. Negative 2 times 1. Negative 2 equals 1 times 4p is 4p. Either the 2 or the negative 1 or the 1 on this side are negative. You can do negative 1 times 4p and then positive 2 times 1. It'll still work out, but only one of these two numbers will be a negative if you do the cross multiplying. Okay? Also, since you have a 1 and a 1 here, right, if the numerators are the same, that would mean the denominators would have to be the same. So we can just do 4p equals 2, and we have to make sure we have a negative there. Okay? And then if we divide both sides of this, okay, by 4, we get p equals negative 1/2. Okay? So p is negative 1/2. That means this is going to be a parabola opening to the left. We know that. So the focus is going to go to the left of the vertex. Right? If this is going to be a parabola that opens this way, the focus is over here. And the p-value tells us how far away from the vertex we need to go. So the focus is going to be 1/2 unit to the left of the vertex. So that p-value means we're going to have a focus right there. They're really close to each other here. So that's the vertex. That's the focus. The directrix, okay, the directrix will be 1/2 unit on the other side of the focus. It would be a line here, right, that goes through at 1/2. Okay? That's x equals 1/2. That's the directrix. Okay, again, we get that from the p-value. The p-value, 1 over 4p, equals whatever this is in front of our either y squared in this case, or if it's an x squared. So this value here equals 1 over 4p. We can solve for the p to know how far away the focus and directrix are from the vertex, which is that red dot. So identify the vertex, we did, 0, 0. The focus, boom, right there. Directrix, this line. Okay? And we want to sketch a quick graph, so now we can take where the vertex is, and we know it opens to the left, and there's our parabola. Let's see another example here. This is going to involve something we've practiced called completing the square. We want to get this equation to look like the one where we have an, x minus h squared, all right? So in order to do that, we have to complete the square. So we're going to see how this applies to working with this equation for a parabola. We're going to have y equals, we have x squared minus 4x plus some value to complete the square, and then we have a plus 1. Okay, we can't just ignore that. So if you recall, we want to take this b value and divide by 2, and then square it, and that's what will go here. So negative 4 divided by 2 is negative 2, squared would be a 4. So we're going to fill in a 4 here. We can't just add a 4 just because we want to. So if we also subtract 4, now it's like we added 0 onto that side. We added 4 and subtracted 4. So we really didn't change the value of the equation. The reason we do that is so that now we can write this as a perfect square. Right now we can write this term here, this part we completed the square on, we can write that as a perfect square. That's going to be x minus 2 squared. And then 1 minus 4 would be a negative 3. So we have y equals x minus 2 squared minus 3. Now it looks like the equation we have with the h, the k, the 1 over 4p. Okay, remember there would be a 1 in front of here. There's nothing written, so there's a 1. So we got to keep that in mind when we go to do our work with that part. Okay, so we've got an equation of completing the square helps us to be able to have a perfect square there, that we have an equation now for the parabola that we can work with. So now we can identify the vertex. Okay, so let's identify the vertex. The vertex, okay, is going to be at 2 comma negative 3. We also see that it's a y equals with an x squared, so we know it's opening up or down. And since this is a positive, right, it's a positive 1 that would be here, it opens up. So this is going to be a parabola opening up. So that's important to think about as well from the beginning here. So we're going to go to 2 comma negative 3, and there's our vertex. All right. Now we want to find the p-value, because to get the directrix and focus, we need the p-value. So we're going to have 1 over 4p equals 1. Right? Where did I get that 1 from? This 1 comes from right here. There's a 1 there that we don't have to have written. So 1 over 4p equals that number in front of the x squared. So 4p equals 1, which means p equals 1/4. Okay, p equals 1/4. So now, opening up means I'm going to go 1/4 above that point and 1/4 below it. 1/4 below it is my directrix. Okay? And 1/4 above it, that's my focus. Right? The red dot is my vertex. And it's opening up. I can draw a graph that opens up. And there's my graph. I got the vertex. Again, by doing the completing the square, I was able to get an h and a k value. An h and a k value. Remember, it's x minus h, so that's why the h is a positive 2, plus k, so the negative 3. There's my vertex. Okay, 1 over 4p will always equal this number in front of the x squared or y squared, so we can solve for p. That tells us how far the focus and directrix are from the vertex. Okay. And if we wanted to write out the equation there for that directrix, right, it would be y equals negative 3 and 1/4. It's at negative 3 and it's another 1/4 below that. Okay. The focus, if we're going to write coordinates for it, okay, that's going to be 2 comma, not 3 comma, it's only over 2. Get my x value wrong there. It should have the same x value as the vertex. Okay, it does. It's 2. And then it's 1/4 above negative 3. So it's negative 2 and 3/4. Or if you have it as a decimal, that's fine. So we want to make sure we know how to take those standard equations know how to use the h and the k with the vertex, and the p-value, the distance that the vertex is from the focus and directrix. Remember, the focus and directrix are always at the same distance from the vertex. The vertex will be in the middle of them. So we're going to keep working with these. You're going to be able to write equations, draw the graphs, get comfortable working with focus and directrix, which are new, and that p-value, which helps us identify where those go on our graphs, and what that vertex looks like to help us know if we're opening up, down, left, right. So those general forms are going to help you know if it's a y equals or an x equals, which type of parabola you should be expecting.